So here I'm sitting outside and it's windy and this lamp here is blowing, so you're getting some funky light effects, but as I said, I'm not going to worry too much about the aesthetics of these recordings. Okay, so let's move on to transportation sector. These are the emissions from global CO2 in terms of different modes of transportation. So this is based on global transport emissions in 2018, which totaled 8 billion tons of CO2. Transport accounts for 24% of CO2 emissions from energy. Remember, we looked at energy and the big part of it was transportation sector, because all the transportation we have right now are running on energy of various kinds. Road passenger vehicles like cars, motorcycles, buses and taxis contribute 45.1%. Road freight transport, trucks and lorries contribute 29.4%, with aviation 81% passenger and 19% from freight contributing almost 12%, and shipping and then contributing about 11%, and then there are rail and other modes which use oil, gas, water, steam and other materials. Okay, so this is good to look at because it also gives you a sense of where mitigation strategies may be most effective, right? Like public transportation could reduce a lot of these, and active transportation like biking and walking could reduce a lot of these. Flying less could help this, and of course shipping fewer things, or making the trucks and lorries run on, let's say, biofuels could make a big difference as well. Carbon footprint of travel per kilometer, another way to look at this same data in 2018. Carbon footprint of travel is measured in grams of carbon dioxide equivalents per passenger kilometer. This includes carbon dioxide but also other greenhouse gases and increased warming from aviation emissions at altitude. Okay, so domestic flight is a big whopper, 255 grams per kilometer. Medium car petrol, medium car diesel, short haul flights, long haul flights. Long haul flights actually cost less than domestic flights because the takeoff and landing are the big emitters, and then once you're cruising at high altitude for long flights, the per kilometer carbon footprint actually comes down. Buses, motorcycles and so on down here, railroads are way down, right? Eurostar International Rail and foot passenger ferry is also in here. So again, this gives you a sense of where strategies can be developed to reduce emissions per kilometer. This is global CO2 emissions in transport by mode in the Sustainable Development Scenario going from 2000 to 2070, just to give you a sense of where the strategies are imagined in a sustainable development. So here dotted lines indicate the year in which various transport modes have largely stopped consuming fossil fuels and hence no longer contribute to direct emissions of CO2 from fossil fuel combustion. Residual emissions in transport are compensated by negative emission technologies such as BECCS, which is bioenergy and carbon capture and sequestration, and DAC, which is direct air capture of carbon dioxide, in the power and other energy transformation sectors. So this sustainable scenario calculation does some future scenarios which are combinations of BECCS, DAC and transformation of energy. But you can see that the ramping down of the emissions in terms of gigaton CO2 per year in various sectors like aviation, shipping, medium and heavy trucks, buses, minibuses, including passenger cars and rail, have to come down to meet our sustainable development scenario targets, which are consistent with the global warming targets as well. And another way to look at it, this is from EPA, sources of transportation air pollution. So smog and soot affect health and welfare. CO2 and other greenhouse gases cause climate change, which also affects health and welfare. So on the road you have light duty vehicles, heavy duty vehicles, motorcycles, and non-road transportations include what we already saw: aircraft, non-road diesel like tractors and so on agricultural land, marine engines, ocean vehicles, locomotives, lawn and garden and recreational vehicles over the ocean, and snowmobiles and so on. So emissions reductions obviously will lead to cleaner air and better health. So solution for transportation air pollution envisioned here are catalytic converters, fuel standards, engine technologies, transmission technologies, diesel filters, alternative vehicle technologies, and better transportation planning. Okay. Another way to look at it is that overall greenhouse gas reduction goals in transportation will focus on vehicle technology, fuel content, so biofuel, solar, electric, and so on, and vehicle miles traveled. Under vehicle miles traveled, you would worry about transportation, pricing, and land use, how the land use affects vehicle miles traveled, and so on. So in other words, there are multiple levels at which the overall sectoral components can be used to strategize to reduce the greenhouse gas emissions. In this case, we are worried about the transportation sector. Okay, so what are the co-benefits of climate change mitigation strategies in land use and transportation? Here, land use is considered part of the transportation because infrastructure for transportation always includes land use. Coastal highways, bridges, tunnels, waterways, whatever you can think of, always include land use, just like agriculture always includes land use, right? So mitigation strategies range from smart growth, lower vehicle miles traveled, reduced speeds, low carbon fuels, and fuel economy. So intermediate impacts include here things like increases in active transportation, which decrease premature mortality. Reducing VMT increases physical activity as well, decrease cardiovascular disease, diabetes, depression, osteoporosis, obesity, breast and colon cancer, increase in social connection and well-being. This is now very well known that loneliness kills a lot of people across the world, especially in rich countries. Possible increase in bike and pedestrian injuries, so that could be a negative outcome of using active modes of transportation. Decreased air pollution, decreases in respiratory diseases, asthma, cardiovascular diseases. Reducing speeds leads to decreased air pollution, lower vehicle speeds, and decreases in noise, which lead to decreased respiratory diseases, asthma, cardiovascular diseases, motor vehicle and pedestrian injuries, fatalities, CVDs, increased well-being, and so on. This is the noise-related deafness issues. Lowering carbon in the fuels is unclear and mixed in terms of intermediate impacts, but possible land use changes occur. So possible increases in food prices could occur, which is the competition for biofuels versus food security, food grains, availability for feedstock or for poor people, for example. Possible population displacements, so land use change for biofuels can happen. Fuel economy, decreased particulate matter and air pollution leading to decreased premature mortality, decreases in respiratory diseases, asthma, and cardiovascular diseases. Okay, so that's the short summary of how transportation sector is affecting emissions and how strategies can be developed for reducing emissions from transportation sector, and what kind of co-benefits those mitigation actions in the transportation sector will have co-benefits for human health. Okay, so this is different than just worrying about transportation sector impact on climate. We are talking about reducing emissions from climate sector, from transportation sector using mitigation strategies and looking for health co-benefits. That's the goal of this chapter. Okay.